Hi, this is Dr. Dave, and in this video I want to run through an activity with you that will give you an idea of how important that area is to antiderivatives. So what you see in front of you here is a graph of the marginal cost. It's the derivative of the cost function. The formula is 4x plus 2, and we know it's a derivative because of those units, thousands of dollars per AC unit. The per means that this must have come from a slope. So what I'm going to do is I'm going to find the area here going from 1 to 9 below the curve but above the x-axis. So let me draw that in here. So from 1 to 9 below the curve and above the x-axis. So I'm trying to find the area of that region inside there. Now, because this is a nice straight line on top, this is actually a geometric figure. So I'm going to break this up into two parts. One of them is going to be down here, and it's a big rectangle. The other one is up here. It's a triangle. And I'm going to use the dimensions on the grid and the function to help me find out what those areas are. So let's start with the easier one, which is this blue one down below. So I'm going to do the width times the height. And so this has a width of 8. And its height, these are 2 units apiece here, these boxes, is going to be 6 high. I can be a little bit more precise because if I put 1 into the formula up here, 4 times 1 plus 2, that gives me 6. That's an even better idea of how high it is. So this has an area of 48. All right, now let's look up at that triangle. All right, the formula for triangle is 1/2 base times height. So this is going to have an area of 1/2. The base is 8 wide. And the height, well, let's see. If I look up to here, it appears to go up to 38. Let's check that by putting 9 into the formula. So 4 times 9 plus 2 is 38. So from the axis all the way up to the curve was 38. However, the blue part of it here was 6 high. So that means that the height of the triangle must be 32 high. So 1/2 times 8 is 4. 4 times 32 gives me an area of 128. So I have 128 here. Below it, I have 48. So that my total area, and because I'm using formulas from geometry, this is going to be exact, is 48 plus 128. If we work that out, that comes out to be 176. Now, let's put some meaning to everything here. When we went ahead and worked out the 8 and the 6 and the 8 and the 32, I didn't take into account the units. So when we said that these were 8 units wide, well, it was 8 AC units. So this 8 is in AC units, number of air conditioners. The 6 is a height, and remember that was thousands of dollars. Per AC unit. So when I multiply these together, the AC units drop out. This number 48 must be in thousands of dollars. So $48,000. Now, the same thing is true up here on our other one. The 8 here was in AC units, or air conditioner units. The 32 is in thousands of dollars per AC unit. The 1/2 doesn't have any units. It's just saying that's part of the formula. When we cancel these out, we end up getting thousands of dollars. So when we add the 48 thousands of dollars plus 128 thousands of dollars, we get $176,000. So what's interesting about this is that the marginal cost function here is in thousands of dollars per AC unit, but the cost function should just be in thousands of dollars, and that's what we just got. And in fact, this $176,000 does have something to do with cost. What it is if we increase our production from 1 to 9 AC units, this is the amount that our costs will rise. So what we have here is the increase or the change in cost when production increases from X equals 1 AC unit to 9 AC units. So the idea behind this part is area basically undoes a derivative. All right, so let's look at the next graph we have here. This is the graph of marginal revenue, and it's a derivative. So if I were to do area on this, I would expect that it's going to give me back information about the revenue function. In fact, it's going to give me a change in revenue. So what I need to do is I need to find the area under the curve. So from 1 to 9, that's what's specified here. Under the curve, like so. Now, in the previous problem, we could calculate that area exactly because we could think of it as a rectangle and a triangle. However, now we have a curve here, and we're not going to be able to do that. So instead, what we're going to do is we're going to approximate the area. And we're going to approximate the area using 4 rectangles. So we're going to approximate the area under the curve and above the x-axis from x equals 1 to x equals 9. And what this will give us when we're done is an idea of the change in revenue when production is increased from x equals 1 to x equals 9. So the first thing I need to do is draw these rectangles in, and I'm going to draw them in a specific way. I'm going to use 4 rectangles here. You could use a different amount. But if I need to put 4 rectangles from 1 to 9, that's a total of 8 units. That means that each one of these rectangles has to be 2 wide. So let me draw the base of the first one. It's going to start at 1 and go to 3, so it's 2 wide. Go from 3 to 5, 5 to 7, and 7 to 9. I'm going to draw these rectangles in a very special way. I'm going to draw them so that it goes up and touches the curve on the left-hand side of the rectangle and then goes across. Because of this, we're going to call this a left-hand sum. Sometimes you'll see it written as LHS, maybe with a 4 after it to say that there's 4 rectangles. Or you might just see it written as L4. So the next rectangle is going to go up and touch on the left-hand side, go across. The next one's going to go up and touch on the left-hand side, go across, and the same thing for the last one. So all we need to do is figure out the area of each one of these. And we're halfway there because each one of them is too wide. So if I take the first rectangle, its width is 2. Now I just need to find the height. And if I look at this, it looks like it's a little bit higher than 2. Now, the good news is we have the formula right here. So I can go ahead and put in y equals, so 0.4 x squared plus 2. Put it in the same window here, so from 0 to 10, increments of 1, and then 0 to 40 in increments of 10. And I should see pretty much the same picture. But the bonus is now I can hit the trace button, and I know to get the height of that rectangle, I need to put 1 into this function. So let me just trace to 1. Its height must be 2.4. So this rectangle is going to have a height, or an area, of 4.8. Now let's do the same thing for the next one. It also has a width of 2, but its height comes from putting 3 into the function. So let me trace to 3. And that has a height of 5.6. So 2 times 5.6 is 11.2. Go to the next rectangle, do the same thing. It's going to have our width of 2. And now when I put 5 into the function, it has a height of 12. So 2 times 12 is 24. And now last rectangle. It has a width of 2, and its height comes from putting 7 into the function. So it has a height of 21.6, which means, let's see, 2 times 21.6 is going to be 43.2, I believe. Yeah. So if we add those all up, that's going to give us an approximation of the area. So let me go ahead and do that. So we're going to take 4.8. We're going to add 11.2. Add 24. Add 43.2. And we get a total of 83.2. Now, we're trying to find the area in that green part here. What we're actually finding, we're approximating, is the area in these blue areas. And so that means we're missing these big pieces up above between the top of the rectangle and the bottom of the green curve. So this is going to be an underestimate. But each of these widths is AC units. The heights are thousands of dollars per AC unit. When you multiply them together, this is going to come out to be in thousands of dollars. So when we increase production from 1 to 9, we're going to have an increase in revenue of $83.2 thousand. However, this is not the only way I could draw these rectangles. These were left-hand sums. If I were to do a right-hand sum, these rectangles would all go up and touch on the right-hand side. So let me draw those in here. So I'm going to go from 1 to 9. So the first rectangle goes from 1 to 3 because it's too wide. Same thing for the next one. Same thing for the next one. Same thing for the last one. Now before, when I drew the first rectangle, I touched the curve on the left-hand side. Now I'm going to touch it on the right-hand side. This is going to be called a right-hand sum. So RHS 4, because we have 4 rectangles, or we could call it R4. The next one is going to go up to the curve on the right-hand side, go across. There's that rectangle. Go up on the right-hand side, touch the curve, go across. There's the next one. And then we do the same thing for the last one. We're trying to find the area, remember, under the blue curve. So that was that piece that looked kind of like this. And clearly, the area in that green part is going to be lower than what's in our magenta part here. So when we work out the areas of these rectangles, this is going to turn out to give us an overestimate. So let's work it out. We're going to take that first rectangle. The width is 2. To find the height, I need to go back to my graph, and I'm going to trace, and I'm going to put 3 into the function. So it's 5.6 high. The next one is 2 wide, and its height comes from putting 5 into the function. So it's 12 wide. Do the same thing, 2. Now I put 7 into the function. We get 21.6. And then the very last one, I'm going to put 9 into the function. So it's going to be 2 times 34.4. Add these all up, and that's going to give us our approximation for the area. It's going to be an overestimate. So I can put that into my calculator to figure it out. 2 times 5.6 plus 2 times 12 plus 2 times 21.6 plus 2 times 34.4. And I get 147.2. And just like the other rectangles, this comes out to be thousands of dollars. So an overestimate of the increase in revenue from 1 to 9 units is $147.2 thousand. Now, one thing to notice, sometimes it's easier to calculate this by factoring out a 2 from each of these, in which case you'd have something like 2 times 5.6 plus 12 plus 21.6 plus 34.4. That'll give you the exact same answer as the other one, but sometimes it's a little bit easier to type into your calculator. So I know that my answer for the exact area has to be between 83.2 and 147.2. So our left-hand sum and our right-hand sum in this case kind of brackets our answer. So what I challenge you to do next is what we call a midpoint sum. A midpoint sum works just the way as the left and the right. So if I use 4 rectangles, the first one would go down here from 1 to 3. Next one would go from 3 to 5, 5 to 7, 7 to 9. The difference on a midpoint sum, though, is now the rectangle takes its height from the midpoint on the rectangle. So the midpoint between 1 and 3 is 2. So the rectangle goes through the curve at that point. So the next one, the midpoint's 4. So it's going to go right there through that point. Midpoint of the next one is 6. So there's the top of the rectangle. So basically the curve is going to touch on the midpoint of the rectangle. So based on what we've just done, you should be able to figure out what each one of these areas are. I'm going to pause the video now. I want you to do the same thing, and I want you to work out what that sum is, and then restart the video, and I'll show you what the answer is. All right, so I've gone ahead and worked out what my area is for each one of these. You see the numbers here. I pulled the two out, added those together, and I got $112,000. This particular estimate is a pretty good one because part of the rectangle here is an overestimate, part of it is an underestimate. They almost balance each other out, not perfectly, but they're pretty close. So this is probably a really good estimate. However, we don't know whether it's an over and under at this point. What we can say, though, is when we do left-hand and right-hand sum for either a function that's always increasing or always decreasing, those two numbers are going to bracket the answer. Now, you might think that this process we've been doing, it can be pretty cumbersome if you have to do more than 4 rectangles. Luckily, Desmos has a little app within there, the Desmos, that will calculate these sums for you. You should be able to do 4 rectangles by hand because you're going to be doing that on your final exam. However, if you need to do more than that, go ahead and search under Desmos Riemann sums, or go to the web address that you see on top here. And what it'll do is it'll open up a version of Desmos here with some rectangles drawn in here for a crazy trigonometric function. All right, I'm going to go ahead and change this formula to the one that we're using, which is 0.4x. I'm going to hit the caret key on the keyboard, 2, right arrow key to get out of the power, plus 2. That's what we were using before. Now, we're going to be going from 1 to 9, and so the A and the B tell you what the limits of your area are. So we're going from 1 to 9. And let me grab hold of this, bring it down here, maybe zoom out a little bit. And if I can't get it precisely the way I want, I can hit this monkey wrench here. Let me do my x-axis from 0 to 10 in increments of 1. And then the y-axis, let's go from 0 to 40 like we had before in increments of 10. Maybe move that up a little bit. And what you see right here is that area we were trying to do. However, it's for a lot of rectangles. If we go down here and type in 4, that's the left-hand sum we did. See, each one of the rectangles touches on the left-hand side. If I want to use more rectangles, I just change that end number. I could do 8. I could do 16. I could do 100. But what you notice as you use more and more rectangles, you're still getting an underestimate, but the area that you're underestimating it by it's getting much, much closer to the actual area. And in fact, we could put in 1,000 rectangles here. We'd probably get almost the exact area because we'd be having very little that we're missing. Let's go back to the 4. Let's scroll down. And this right here is what we call a Riemann sum. The sigma just means that you're summing things up. You're summing up f's, which are heights, times widths. And the number that it says we get is 83.2, which is precisely what we got when we did it by hand. If we want to choose to doing a different kind of sum, it says in here, choice of method, set c equal to 0 for left-hand sum. That's what we're doing. C equals 1 for right-hand sum. So there's our right-hand sum. It gave us 147.2, just like it was before. Notice that each one of the rectangles touches on the right-hand side. And if we put in 0.5, it's going to give us the midpoint sum. And you see that the rectangles are passing through the curve at the midpoint of the width. And we get that same number, 112, that we did by hand. So this is a handy little thing that you can use on your homework. However, make sure you practice by hand on the PDF of what I was just working out a moment ago, and also for some of the problems on the homework. The other ones, I don't mind you going ahead and using this. All right, well, that's all for now, and hopefully that's going to be helpful to you as you work through your homework.